Hello everyone, this is Professor Nelson from Electronics. This time, I'm going to show you how to make a temporary soldering iron for those times when you need it. For when your soldering iron has broken and you need to keep soldering. For those times, it's good to have a temporary soldering iron. And to make one, we're going to use N-channel Mosfet transistors, like these ones here. These are Mosfet transistors of different models. For example, this one is the IRF840. And this one is the IRFZ44N. Almost any Mosfet transistor can be used to complete this project. However, it's good to know exactly which transistors you can use. Well, for that, it's good to know some theory. So, let's look at that theory. Alright, guys, for the theoretical part, you need information about both transistors. Among the most important characteristics of Mosfet transistors, we have three. As you can see here, we have the working voltage, the resistance the transistor offers when activated, and the current the transistor handles. As you can see, the characteristics are very different for the two transistors. The IRFZ44N operates up to 55 volts and offers 17.5 milliohms and can handle 50 amps. In the case of the IRF840, it can handle 8 amps and it can operate up to 500 volts. But the resistance it offers when activated is 850 milliohms or 0.85 ohms. The most important characteristic for us is the so-called RDS, which is the resistance the transistor offers between drain and source when the transistor is activated. This has 850 milliohms, which is much greater than 17.5 milliohms. This characteristic will make the 840 heat up much more than the IRFZ44N. Why? Well, for the following reason. Okay, in this case, we have the following circuit, which we're going to put together to confirm the fact that one of the transistors will heat up more than the other. And here we have a series circuit consisting of our 1 and the Mosfet transistor, powered by a 12-volt source. Now, when the Mosfet transistor is activated, it supplies 12 volts through pin 1, or the gate. The transistor should behave like a switch, offering zero resistance. However, based on the characteristics we just saw, the IRFZ44N will offer 17.5 milliohms of resistance. Therefore, the voltage drop across the transistor will be quite small compared to the value of R1, which is 3.3 ohms. In the case of the IRF840, it says it offers 840 milliohms, which is much higher. Therefore, the voltage drop across the Mosfet transistor will be much higher than that of the IRFZ44N. Therefore, if we multiply the voltage by the current that will flow through both components, this indicates that the Mosfet transistor will heat up much more than the IRFZ44N. This means that depending on the RDS offered by a Mosfet transistor, it can heat up more or less depending on its value. Well, that would be the theory. Now, let's confirm this theory in practice. So, let's move on to assembling the circuit. Okay, guys, we've already assembled our circuit. And as you can see, we have the negative, we have the positive, the resistor in series with the Mosfet transistor. Pin 1 of the transistor or gate is connected directly to the positive, just as the circuit indicates. And now, we're going to test the IRF840 transistor. We're going to measure the temperature it can reach with the help of our multimeter. Now, I want you to pay attention to the temperature displayed on our multimeter. We're going to connect the power supply. And as you can see, the temperature is rising rapidly. Okay, let's disconnect it. As you just saw, it quickly exceeded 100 degrees Celsius. Now let's test the voltage between drain and source. Very good. Now let's measure the voltage between drain and source. We connect the power supply, and we have more than 3 volts. We disconnect it, and we have 0 volts. There we can confirm that the IRF 840 has a fairly large voltage drop. Therefore, yes it will heat up. Now let's test the IRF C44N to see if it heats up in the same way. Very good. Now let's test the IRF C44. Let's measure the temperature. We connect the power supply. The temperature does not increase. We disconnect the power supply. Notice that the temperature barely rises. However, the resistor has a high temperature compared to the transistor. Now let's measure the voltage between drain and source. Very good. Let's measure the voltage between drain and source. We connect the power supply. And we have only 0.3 volts. We disconnect. And that way we can confirm that there are transistors that will work for our project, and there are others that won't. In this case, the one that will work for us will be the IRF 840, which will heat up quickly, while the IRF C44N will be very difficult to heat up. Well, now let's move on to assembling our temporary soldering iron. Very good, guys. We just finished our temporary soldering iron. As you can see, it's more or less finished. It has a pretty acceptable finish. There we have the connector for the power supply. And it's easy to handle. Well, to power this temporary soldering iron, we need at least a 2.5 or 3 amp 12-volt power supply. This is because we're using the IRF 840. If you use the IRF Z44N, it won't work for you. You'll need a more powerful power supply, and it most likely won't heat up very much. However, this one will heat up, so let's test it. Okay, let's plug it in and see if it heats up. You can see that it's just heated up. And let's see if it melts the solder. Yes, it melts without difficulty. Okay, now we're going to try soldering something. So let's try this board and this wire. Let's take some solder. See how it melts the solder on the wire without any problems. And now we're going to solder it to the board. And you can see that it's completely soldered. And unsoldering it is easy and simple. So, this way you can make this temporary soldering iron for times of need. This doesn't mean you're going to replace your soldering iron with this. But it's helpful and useful when you need something to solder immediately. Okay, guys, this concludes the video. Now, if you liked the video, a like helps the channel a lot. See you next video. Bye-bye.